Factoring trinomials with a positive c value. So if we multiply a binomial times a binomial using a method like FOIL, where we multiply first, outside, inside, last. So far we've multiplied tons and tons of binomials times binomials using FOIL to get like x squared plus 8x plus 15. Well, today we're going to look at being given x squared plus 8x plus 15 and changing it into a binomial times a binomial. So factored form for x squared plus 8x plus 15 would be x plus 5 times x plus 3. So our goal in this section is to rewrite simple trinomials in factored form. So if we start with a trinomial and pretend that we have it as a factor, we have a binomial times a binomial. We know when we do first times first, x times x will give us x squared. So we could fill in this part of the binomials with two x's. And then to figure out what numbers go in these empty spaces, we're going to look at finding the product, or two numbers that multiply to 24 and have a sum of 10. So to find the correct factorization, we must find two numbers with a sum of 10 and a product of 24. And most of us can probably come up with that if we sat here for a couple minutes and started to run through those factors. But let's say we didn't come up with it right away. Well, we could take this 24 and we could just list the factors. So let's just make a little table and list the factors of 24. Well, 1 times 24 is 24, 2 times 12, 3 times 8, 4 times 6. And then if we add our sets of factors, 1 plus 24 is 25, 2 plus 12 is 14, 3 plus 8 is 11, and 4 and 6 add up to 10. So the two numbers that worked, 4 and 6, multiply to give us the last term of 24, but add up to the middle term of positive 10. So these two missing factors are positive 4 and positive 6. And if we factored correctly, we should be able to multiply and get back our original problem. So we could take this x plus 4 times x plus 6. X times x is x squared. Outside is 6x. Inside is 4x. Last is 24. We combine like terms, we get x squared plus 10x plus 24. So we can tell that this x plus 4 times x plus 6 is an equivalent expression to x squared plus 10x plus 24. All right, let's look at a new one. Oh, does order matter? Well, when we multiply 2 times 3, we get the same answer if we multiply 2 times 3 or 3 times 2. So order doesn't matter when we multiply. So x plus 4 times x plus 6 is the same as x plus 6 times x plus 4. We would get the same answer if we multiplied that out. So those are two equivalent expressions as well. So order does not matter when you multiply. All right, let's look at a new example. We have x squared plus 7x plus 12. So to factor this, I want to ask myself what two numbers multiply to 12 and add up to 7. Have a product of 12 and a sum of 7. Well, x squared we're going to break up as x and x. We're going to multiply to 12 and add up to 7. So I think I can do this one in my head without a table. So 3 times 4 will give me 12, and 3 plus 4 will give me 7. So my factored form, x plus 3 times x plus 4. And I can always check that by multiplying and combine like terms, and I get back the original problem. So my factored form would be x plus 3 times x plus 4. All right, you guys try this one on your own. Factor x squared plus 5x plus 6. Pause the video here, come back, check, see how you did. All right, so I'm looking for numbers that have a product of 6 and a sum of 5. Two numbers that multiply to 6 and add up to 5. Well, I'm going to break up my x squared as x and x. And 3 times 2 will give me 6, and 3 plus 2 will give me 5. So my factored form, x plus 3 times x plus 2. And I can check by using FOIL. First, outside, inside, last. Combine like terms, and it is equivalent. So if the product of two numbers is positive, what do we know about the two numbers being multiplied? If my answer is positive, then the two numbers being multiplied would either both have to be positive or both numbers would have to be negative. So for example, if I have r to the fourth minus 34r squared plus 64, in this case I'm looking for numbers that multiply to positive 64 and add up to negative 34. So right away I know the signs are going to both be negative. To multiply and give me a positive number and add up to a negative number, they must both be negative. This r to the fourth, I can break that up into r squared times r squared. And then I just have to look at a list of factors. And this one's not quite as obvious. I might have to make a table and start with 64 times 1 and 2 times 32 until I come up with, well, 2 and 32. They multiply to positive 64 and they add up to negative 34. As always, we can check with multiplication. So if your product is positive and your sum is negative, then both numbers would have to be negative. All right, what if we have two different variables? This one we have m squared minus 27mn plus 72n squared. Well, with the two variables, when I do first times first, I can get the m's. But when I do last times last, n times n would give me n squared. So I'm going to write these n's kind of at the back of the parentheses. Then I'm going to ask myself, what two numbers would multiply to positive 72 and add up to negative 27? Well, in order to multiply and be positive and add up to negative, they have to both be negative numbers. Now, 72 has a lot of factors. I could start listing those, 72 and 1, 2 and 36. And when I get to 3 and 24, negative 3 times negative 24 will give me 72. And negative 3 plus negative 24 will give me negative 27. And we can check with multiplication, get back the original problem. So by checking, we know that the two expressions are equivalent. Now there's something called prime. So a polynomial with integer coefficients that cannot be factored into polynomials of lower degree, also with integer coefficients, is called an irreducible or a prime polynomial. Meaning if we can't factor, if there's no factors that'll work and the only thing it's divisible by is 1, we would just write prime. Now you can't write prime for all your answers. All your questions in math and algebra are not going to be prime, but don't be surprised on occasion you'll run into one or two questions where they won't factor and they will indeed be prime and you'll write the word prime. So I hope that gets you help started factoring trinomials. Remember with this positive last term is going to indicate that you either have two positive numbers or two negative numbers when you're factoring. Have a great day. OUT spells out.